Okay, I'm on page 111 of your interactive notebook. You are going to need a highlighter for part of the notes for this lesson, so you can go ahead and grab one from your supply box, and then remember that you can pause at any time if I'm going too fast for you. Go ahead and title your notes the quadratic formula, and then write down the quadratic formula. X equals negative b plus minus the square root b squared minus 4ac all over 2a. So divided by 2a. It's a mouthful, and it could look a little bit scary because you have all of these like weird symbols like plus and minus that we're not used to seeing. We have a square root and then a bunch of letters and numbers inside the square root. But when we get to the examples, you're going to see how easily these things simplify. And you just kind of start getting rid of numbers, you start simplifying things, and then you can get to a final answer that looks much simpler than what you start with. We can use the quadratic formula to find any solution to a quadratic function. So sometimes your factors of a quadratic aren't as simple as like 3 and 4, for example, or a third and 2/3. Sometimes it requires us to find something a little bit more complex, and the quadratic formula helps us to do that. Before we get started with an example of the quadratic formula, I want to go ahead and review simplifying radicals. So I messed up on a previous video, so I had already done this part, but I'm going to go ahead and explain it since you haven't gotten the explanation. But when we simplify radicals, we start off with a radical such as square root 40. You can use the factor tree to factor out the prime numbers for the one that's inside your square root. So for example, 40 is a product of 2 and 20. 2 is prime, so I circled it. 20 is not prime, so I keep going. 20 is a product of 2 and 10. 2 is prime, so I circle it, but 10 is not, so I keep going. 10 is a product of 2 and 5. So this right here is a 2, and that's a 5, and both of those are prime numbers. Once you have your prime numbers, you can take pairs of those prime numbers and simply take that number out of the square root, and whatever numbers are left that don't have any pairs go inside of your square root, multiply. So this 2 and this 5 don't have anything to pair with, so I'm just going to go ahead and multiply them. 2 times 5 gives me 10, so I get a 10 on the inside. Okay, then square root 52, another method that we looked at was the birthday cake method, where you start at the bottom with the number 52, and then you create like layers of a birthday cake. Always try to start dividing by 2. So if I divide this by 2, I get 26. I can divide that by 2 to get 13. And 13 is a prime number, so I can divide it by itself and get 1, and that's my birthday candle. Then you look for the pairs of numbers. I've got a pair of 2s. You write it on the outside of the square root. I'm going to write it here. And then on the inside is whatever's left over. So in this case, I have a 13 left over. So the square root of 52 would be the same as 2 times the square root of 13. And this is just the short review of how to simplify radicals. You should have some notes in your notebook about it as well if you want to go back and see. You need to know how to simplify radicals to be able to successfully apply the quadratic formula. Okay, we're going to move on to our example. But first, I want you to write the standard form of a quadratic function. The standard form is ax squared plus bx plus c equals 0. Don't forget that equals 0. The examples I'll show you today will all be in standard form, and later on we'll mix in more problems that require you to turn the functions into standard form. So here's your first example. X squared minus 4x minus 7 equals 0. We're going to use the quadratic formula to solve for x. So remember, there should be two solutions for x. Our first step, move this paper over here because I don't want you to get overwhelmed. Our first step is, well, first we got to check to see if it's in standard form. Well, we've got the x squared term, we've got an x term, and we have a constant, and they're equal to 0. So this is in standard form. The next step is to identify a, b, and c. In this case, a is 1, b is -4, and c is -7. Once you've identified a, b, and c, then you can go ahead and substitute them into your quadratic formula. I've written like a skeleton version of the quadratic formula, and I'm going to go ahead and plug in the numbers. I want you to compare with the actual quadratic formula that you see on your notes, and then see the numbers that I'm plugging in. So I know x equals -b. In this case, b is -4. So x equals the negative of -4 plus or minus the square root of b squared. B is -4, so I'm going to plug in another -4 minus 4 times a times c. A is 1, c is -7. All divided by 2a. A is 1, so I'm going to plug in a 1 here. Again, if I'm going too fast, go ahead and pause. Make sure you have this written down exactly the way I do it. Okay, at this point, I'm going to highlight the pieces that I'm going to simplify. So be very exact in what you're highlighting, because where I start and stop the highlight matters. So the things that I'm going to simplify or rewrite are going to be the negative of -4. I'm going to simplify -4 squared. And then I'm going to simplify 4 times 1 times -7. And then 2 times 1. Everything else is going to stay the same. So here's what I'm going to end up with. I'm going to get negative of -4 is simply +4. So I'm going to write +4. Let me change colors here. So it's going to be 4. And then the plus minus stays the same. The square root stays the same. But on the inside, I have -4 squared. If you'd like, you can use your calculator to verify. But -4 squared is 16. Then I'm going to subtract. So minus 4 times 1 times -7 is simply -28. Again, you can pause, check on your calculator, make sure you verify for yourself. And then 2 times 1 is just 2. So I'm going to divide all of this by 2. Okay. The next thing I'm going to highlight is 16 minus -28. So that's the next thing that's going to change in my equation. So I'm going to end up with 4 plus minus 4 plus minus the square root, and then it's 16 minus -28 is the same thing as 16 plus 28, which gives me the square root of 44. Again, you should verify this on your own using the calculator. And then I'm going to divide all of that by 2. So the only thing that changed was the 16 minus negative 28. All right, so here is where simplifying the radical comes in. Because I have a square root of 44 there that I can no longer simplify unless I want this really long decimal. So the next thing I simplify is the whole square root of 44. To do that, you have to know how to simplify a radical. So the square root of 44 is equal to 4 times 11. 11 is a prime number, so I circle it. But 4 is not, so I keep going. 4 is equal to 2 times 2. Both of those are prime. So the square root of 44 is simply 2 times the square root of 11. And now I'm going to take that 2 square root 11 and plug that in for square root of 44. I'm going to go ahead and move over to the next page. If you still have space, then go ahead and continue writing. But I want you to know that what I write next continues from here. So 4 plus square root 44 is going to turn into 4 plus minus 2 square root 11 divided by 2. Go ahead and compare and see what changed, what didn't change, so that you make sure you understand. All right, your last step is to simplify the division. So take your highlighter. You are going to simplify the 4 divided by 2, and then also the 2 divided by 2. So it's kind of like you're making a V here. Well, on your calculator, you can divide. 4 divided by 2 is simply 2. We still keep the plus minus sign. And then 2 divided by 2 is 1. I'm going to go ahead and write it. And then the square root of 11 stays the same. We typically write this, so you can say usually, we write this like this, 2 plus or minus square root 11. Now let me say something about this plus or minus symbol. What this tells you is that you have 2 roots. One of the roots is 2 plus the square root of 11. And the other root is, so you can write 4, 2 minus the square root of 11. These will give you 2 different things. If you want to evaluate them, you can using your calculator. So I'm just gonna, I had done this before. So let's see, 2 plus the square root of 11 is about 5.3, let's just say approximately 5.32. Okay, and then 2 minus the square root of 11 is a negative factor. So this one is approximately negative 1.32. And so essentially what you're going to have is a parabola that's going to touch the x-axis. And this point is going to be 2 minus the square root of 11. And this point will be 2 plus the square root of 11. Oops. Move that over so you can see it. There you go. Label it here. Okay. All right. So I know it's a lot, but it's just notes, and then know that I'm going to come back and show you more examples where we do these together. And also remember that you still have decimals. There are other ways that you can calculate factors. But this is one way that's expected of you to know. So the next example that I want you to try on your own, try to get as far as you can. So you try this negative x squared plus 4x plus 10 equals 0. And this one should be very similar to the one that I just worked out. So try to follow the steps and see if you can figure it out yourself. Tomorrow we'll do more practice.